So thank you very much for spending the time with us here at the ISA Forum. My name is Uli HOMANN. I work for Microsoft, and I spend a lot of time thinking about or conversing with customers and partners around the globe. And this multi-cloud application development, application management is starting to become a very big theme that we at Microsoft certainly are trying to address together with the industry. And I want to share some thoughts with you and some technology investments and innovations that are going on. And obviously would appreciate a conversation and really start to go and have ideally some work afterwards, how the ISA can actually start to really drive this conversation forward. The topic is multi-cloud development. I'll talk a little bit about some of the myth, some of the reality, and hopefully we'll be able to point to the way forward with respect to open innovation strategies around standards and so forth that I believe are critical in making this whole topic work across this wide spectrum of cloud and cloud capabilities and cloud scenarios that people are looking into. Sorry. There is a definition that I would like to share because a lot of people have multiple perspectives of how this multi-cloud topic works. On the one side, you have the placement of solutions on a cloud, but customers using multiple solutions, hosting them on multiple cloud environments. And that I call multi-cloud placement. And then you have cloud agnostic solution development. And that topic is more focused on what I'm going to talk today as part of the way of how you think about software development moving forward, while at the same time trying to figure out how you build software that utilizes the hosting cloud as deeply as possible, while at the same time is something that you can, with effort, move from one environment to the other. I'm not going to talk a lot about SaaS environments because those are even more complex, where every customer has already multiple SaaS clouds in their environment. And certainly that's a topic for another day, but certainly another area which could be fun to chat about at some point in time. Why do customers care? Because while they might have a partnership with Microsoft, they might have a partnership with Amazon or Google or any of this stuff, there still is the notion of, I do not want to have such a deep dependency that I will never be able to extract myself. I think people have had history in various digital ages of dependencies that they didn't feel comfortable about. Therefore, people are really starting to say, how do I build solutions in a way that allows me to move my vendor relationship from one to the other? Cloud computing is the quote-unquote worst of all worlds, because on the one side you have a technology dependency, and on the other side you have a hosting dependency, and cloud combines them both, and therefore leaving or removing one lever that customers used to have, where they actually said, okay, I'm okay with the technology dependency as long as I can take the technology and move it from one provider to the other, or be my own provider. And then if you are in the regulatory business, for example, the European Central Bank, the ECB, requires a bank to show that they can remove a systemic dependency. And clouds, if you use cloud computing as a bank, has been deemed a systemic dependency. And therefore, a customer or a bank in this case has to show that they can remove this dependency within a reasonable time with reasonable effort. That does not mean that you build solutions that can run on one cloud today and run on another cloud tomorrow, but it certainly means that you need to be able to take your assets and data and so forth and move it from one environment to the other in reasonable amount of time. Again, if that's 6 months, 6 weeks, a year, that really depends on the definition of what you believe is reasonable, but that's the way the ECB talks about that. And I've seen other regulators starting to use a similar metaphor and way of thinking about this. If you're a solution developer, you're trying to maximize your margin and your market reach. Why would you constrain yourself to one environment if it's feasible, technically as well as performance, operations, and otherwise, to run your solutions in a way that allows people to deploy them on Amazon or on Google, on Microsoft, VMware, whatever the environment might be. And so for us, or for me, that means these two models effectively will drive the behavior forward, and therefore this multi-cloud conversation is here to stay. And therefore, I think as software architects, we have to start thinking about how do we help in this area. Before we go a little bit into how to solve this problem, I want to talk a little bit about what I call the myth of cloud agnostic applications. Before we go into cloud agnostic, if you have been around the software world in a while or for a while, you will certainly know that a lot of people have been worried about dependencies on database technologies or dependencies on specific operating systems or languages or frameworks or other things. And so this multi environment is certainly not new, but cloud, as I said before, really exacerbates the or compounds the issue, because it's not just a technology dependency, it's also hosting dependency, and making this more complex than before. So I've seen a number of people effectively state the first one: if I use only the most basic cloud service, my application is portable. In the original days of cloud, that meant people used only virtual machine or IaaS technologies and stayed away from PaaS services, because PaaS services are by definition cloud specific and cannot be moved. As we will see later in the presentation, that's actually just not true. And it's also certainly not true that if you're using just IaaS, that the application is automatically portable. As we have seen, moving applications from, let's say, AWS to Azure that were just using infrastructure as a service capabilities, that's very, very complex and hard to do, because each cloud, while having similar capabilities, the capabilities are different enough that using them in an optimized way on one cloud is certainly not optimized on the other environment. The other piece is that you really can't avoid lock-in everywhere. You really need to think about where is portability required and where is lock-in okay. As architects, we know that at the end of the day, it should be a business decision where you use optimized functionality, assuming that the optimized capability is effectively a proprietary one, and where do you use technology that is portable. And it should be something that you do with great thought and great perspective, because at the end of the day, you're looking at how much money are you spending on abstractions, for example, to make your solution independent, rather than building your solution on the cloud native capability and maybe having to develop a capability twice, because the model or the scenario is available on another cloud environment, but not quite in the same way. As I said, it's effectively how much money do you spend on what capability development. And sorry, before I go there, and it's really important to think it through. Once you decide to use a cloud proprietary technology, you then should use architecture as a way to think about, how do I isolate that specific set of functionality that is specific to one cloud environment from the majority of my code that I might want to build with portable technologies. And doing that in a consistent fashion using architecture approaches like service orientation, microservices, whatever the model is you like, is something that I believe is the job of the architect, to help the business decision maker and the technical decision maker draw the right line between portability as well as optimization. If it's open source, I can move it wherever I need to. That is theoretically true, and there's certainly a lot of truth in this myth, where open source, because of its nature, can be adapted. But there are also some pitfalls, I would say, in the open source world, which I believe you need to think about. Where in a world where innovation is plentiful and standards are also plentiful, the innovation keeps moving forward, and it keeps moving at a rapid pace, where standards tend to be much, much slower because of the very nature of getting agreement on something, aligning it with a lot of potentially differing agendas, different perspectives and points of view, and getting to the ultimate decision. The only standard, by the way, that I think works as designed and without any testing, and even there are some holes in there, is TCP/IP. I mean, I just joined from a bed and breakfast here in Crescent City, California, and I never even think about joining a Wi-Fi hotspot. It just works. Most other standards, including things like HTML and so forth, are still subject to interpretation. And if you use different internet engines, you still get different results with respect to the presentation. The other piece, obviously with innovation, you're getting a lot of choices. With standards, you get portability. And again, as with the first myth, it's a trade-off. It's a conversation about how much innovation do you want to bring into your solution? How much business value does a given innovation give you? Let me give you an example. When AWS came out with a Lambda paradigm and the support for the Lambda programming model, which, as you architects know, is just a clever and very well done implementation of the React paradigm, it was effectively super innovative. It was absolutely beneficial for solution development and so forth. And for a while, it was 100% proprietary. You could only run Lambda-based solutions on AWS. And if you were an AWS customer, from my perspective, it would behoove you to think through where Lambda would help you and where Lambda would not be super helpful. And balancing that view is something that I think is really important. Obviously, the other cloud providers, including Microsoft, came up with functions which are similar from a paradigm perspective to Lambda, but have their own proprietary perspectives, although some aspects like the Azure Functions Runtime is open source, but only available today on Azure itself. So thinking through, again, how you drive from innovation and how much innovation you want, how much portability you want, is something that's important. Again, more differentiation in terms of building solutions faster, potentially with higher business value, if you think about AI and other capabilities, to more efficiency and, of course, more portability. The way I think about this is you have kind of 4 levers in here. At the top innovation layer, you have discoveries. Let's use Lambda as our example here, as a thing that came up out of the blue, in quotes, and it was a great solution for software development, and it certainly has taken hold as a paradigm across the board for all platforms. At the other end of the stack, you have the Euro standards, W3C, IEEE, those kind of forums spend a lot of time, a lot of IQ to really get to these standards, HTML, TCP/IP, those kind of things. And then you have 2 in between. Community is effectively the way a discovery travels through the technology maturity stack. A community builds around a specific technology, let's say Kubernetes, or you're doing things like AI capabilities and so forth. All of a sudden you see it's not just one vendor that supports it. It is actually a community of either customers, partners, or vendors that start to rally around a specific capability. And Kubernetes is a great example where it was a discovery of a container orchestrator, but most of you will know that there were quite a few orchestration capabilities around when Kubernetes emerged, and it wasn't quite clear if Kubernetes would make it. But then you saw that a community formed not just about Kubernetes, but there were a couple of other communities as well. But I would say that Kubernetes clearly emerged as a de facto standard. A de facto standard for container orchestration, I don't think there is a debate anymore that is now Kubernetes. If you're looking at document databases, you could argue that MongoDB is this de facto standard. And the trick is to know when you have a community model and when you have a de facto standard. Unfortunately, there is no easy recipe. As one of our Supreme Court judges said, you will know it when you see it or when you hear it, but it's obviously not quite as simple. The Kubernetes example is a great example, going from discovery through community through a de facto standard. Another one is effectively there, it's not quite as successful, is the open cloud innovation that was part of, I'm now breaking, my memory is failing me here. But at the end of the day, you saw a lot of people getting very excited about an OpenStack, that's what it is. OpenStack as a standard. Lots of people got around it, a very large community, lots of investments. But at the end of the day, at least from our perspective, or my perspective today, I don't see OpenStack as being a relevant innovation. So there was a discovery. People thought that that was really important. Lots of community formed around it, but it didn't make it into a de facto standard. We can obviously speculate why that is. Maybe it just didn't innovate fast enough. Maybe the Kubernetes and container revolution came faster and kind of made it not irrelevant, but certainly not as relevant as people thought. I don't really know why the OpenStack innovation didn't happen, but it certainly is a great example where if you bet your horse on OpenStack, most likely you are trying to undo that today. Like a lot of banking companies that I know of, the telcos are still using OpenStack, but they're moving to a container and Kubernetes world as fast as they possibly can as well. This one is a good one as well. Cloud portability is at odds with developer choice. And as we will show you, you effectively have a lot of choice where you can offer de facto standards with options that meet a wide range of developer needs. As an architect, maybe as a CTO, you certainly don't want developers to have complete free-form range to build everything that they might want to do and try this tomorrow and this today. You do want to effectively go and offer some choices. Josh McCanty from Pivotal, or formerly Pivotal, certainly had a good view on this one, where he simply said, hey, from a category perspective, if you are doing data management, you might want to offer 3 different types of data management capabilities. And for each of those types, you might want to offer a specific choice. And here you see a mixture between open source and SQL Server being a closed source system. But SQL Server in this case is okay because you can take SQL Server with you. So while there is a technology dependency, the technology is portable in the sense of you can take it with you to Amazon, Google, whatever the environment might be, and host it there. And last but not least, I want to talk a little bit about the poor operations people, because while this whole notion of microservices and the choices of a full stack solution from user interface, business logic, and data per microservice is something that is very, very positive and powerful and empowering for developers, it can lead to quite a lot of operational overhead for the people that have to operate the solutions. Because if you go and have too many choices with too many opportunities out there, you might have to have high availability, disaster recovery, business continuity, and those kind of concerns for many, many, many solutions that the developers picked for very good reasons. But I do believe you do have to have a balance. The good news is that the industry, driven by various forces, is moving to a model where we effectively are starting to say, actually, if you really look at a system, call it MongoDB or call it Cassandra or any of the other capabilities that you see, especially in the open source world, you really can think of the API or the protocol that you use to access the engine as a separate thing from the engine in itself. If you're able to do that, and again, in an open source world that's possible, you can actually start to say, my application takes a dependency on an API or a protocol. And as long as that protocol is served, I don't really care what the back-end system behind is, because I just look at the API as an abstraction that allows me to participate in this end-to-end ecosystem here. But if the back-end engine is implemented in a different way, as long as it meets my API standard and the protocol implementation is correct, you effectively are able to separate this. And a great example is the Azure Cosmos DB technology, which is a high-end NoSQL database that supports many or multiple interfaces. And one of them happens to be MongoDB. There were quite a few implementations at Microsoft internally with various services that used MongoDB, including the MongoDB engine, that are now successfully moved over to the MongoDB API. One of the very largest retailer in the world was a very large Cassandra user on-premise, and they just moved their Cassandra-based application stack to a Cosmos DB-based system that effectively supports the same Cassandra APIs, but in a way that allows a solution to use Cassandra on the one side, MongoDB on the other side, and some other interfaces. And all the while, the engine itself is a consistent system. And I do believe that this kind of multimodal API capability, separating the protocol from the implementation, is something that, in fact, you will see later in the presentation. But I do believe that that's something where the cloud agnostic part and the cloud optimization part will meet using this paradigm of API separation from the engine capabilities. Microsoft has done this with Event Hub as an eventing technology, but it now supports Kafka APIs. So as a Kafka consumer, you actually don't know that you're not talking to a Kafka endpoint, you're talking to an Event Hub. It's just completely transparent to you. So when you're thinking about what we just walked through is really mostly common sense with respect to how do you balance between proprietary as well as standards? How do you bring in innovation versus sticking to what's proven and true, and balancing that out and thinking through how you balance also the developer with the operations folks. How do I build these cloud agnostic applications and still get optimization for a specific environment? From our perspective and my personal perspective, I believe that the Cloud Native Compute Foundation, the CNCF, is going to be critical on this journey to build a rich set of capabilities that are capable of hosting and building or enabling building of applications, but give enough optimization potential so that the cloud provider, whoever you pick, is able to optimize and integrate the CNCF capabilities in a way that allows you to build these cloud native capabilities, but at the same time, the Kubernetes environment or the service mesh interfaces or other capabilities abstract the system enough so that the cloud capabilities can be still differentiating and capable in other ways. Kubernetes and SMI and other things abstract the capability, but underneath the covers, storage, network, compute can be optimized in different ways to provide differentiating hosting capabilities, starting with simple things, not simple, but important things like compliance and security, all the way to performance, boot up times, and other things that will make the difference. And if you are not yet active in CNCF as either an individual or as a company, I certainly believe that that's an area where it would be great to see more and differentiated investment and support, because I believe that that's the future for how we build applications and how we build the infrastructure that supports those applications. When you're looking at the cloud state of cloud native applications, The cloud is going fully managed. My definition of serverless, by the way, and that might be a little bit weird to some, is effectively the management part of the whole element, not necessarily the programming model part where it originated with the Lambda system, because you've seen a lot of serverless operations and serverless capabilities showing up with data warehouses and others, which have nothing to do with the original event-based model, but are still effectively serverless, where we as Microsoft certainly believe that Kubernetes is dominating the infrastructure in on-premise environments and in edge environments. And the cloud might or might not use Kubernetes infrastructure. It certainly will expose Kubernetes APIs, or broader speaking, CNCF capabilities, however it's implemented. And application developers need to know what the infrastructure and code effectively can do to deploy the solutions on the necessary target environments. Why do we leave fully managed in the cloud and Kubernetes on the edge and on-prem? It depends on the operating model that the customers apply. While I will talk a little bit about where hybrid management is going later in the conversation, there is going to be a need to go and debug potentially an on-premise environment. And having a standardized system with standardized access like kubectl and those kind of capabilities is going to be important as part of being able to manage an environment. Therefore, as an application developer, you need to make choices that are relevant for your app, but you also need to think about how do I debug and troubleshoot a solution where I might or might not have access to the specific infrastructure at hand. So we've talked about the goodness of CNCF, and I believe it's certainly a core building block of what's going on. But when you're looking at most investments that the CNCF is currently pushing, you actually see infrastructure being the key part. In any case, if anybody of you believes that Kubernetes is something that helps the application developer building applications, I don't think most people would agree with you, because Kubernetes is a pure infrastructure operations piece where, yes, it makes it easier to deploy into solutions into such an environment, but things like debugging, troubleshooting, service-to-service invocation, various programming paradigms, even things like events and others are not something that a Kubernetes environment by nature will care about. So from our perspective, we are missing, as the next step up in the journey towards a cloud agnostic, cloud native programming model, is something that we are missing. So Microsoft has been investing in this notion. I assume all of you know what a programming model is. Here is just an example of how you think about various invocations. How do you build it with state and stateless environments? How do you deal with secrets management? And how do you do this in a way that allows you to use Go in one environment, Python in another, Rust in yet another service, and having a capability that speaks to all of these various environments in ideally non-invasive and optimized fashion. So Microsoft and partners have been working on an open source initiative called Dapr. Dapr stands for the Distributed Application Programming Runtime. And it's a portable, event-driven runtime that helps you building distributed applications using the microservices paradigm. It is built as a sidecar, so effectively you bind yourself to the APIs of Dapr, and the Dapr system gets injected into your application using this paradigm that gets very popular in Kubernetes, but obviously is possible and capable in other environments as well. Building microservice building blocks, effectively a lot of the capabilities that I just rattled off, like things like service-to-service invocation, troubleshooting, debugging, and those kind of things, and making it available in a way that is optimized and capable of running inside Kubernetes, but also able to run in other environments, because Kubernetes, while it's certainly growing both beyond the data center into edge environments, it might not be able to run everywhere. What if you would like to build desktop applications, be that Windows desktops or Macintosh environments, building a standalone app? How would you build that? If it's Kubernetes-based, most likely that makes no sense to deploy on a desktop today, and therefore Dapr is not bound to Kubernetes, but has a implementation that is optimized for Kubernetes. It's called Rudder. We're not going to talk about Rudder much here, but if you're interested, it's RUDR, Rudder, as an implementation of the Dapr environment for Kubernetes. As I said before, Kubernetes, or Dapr, sorry, is an application environment that allows you to use any language with any framework, so whatever you like. And the invocation is either over HTTPS or gRPC. And here is the list of initial microservices that the community around Dapr has been building. And the interesting thing is, for you, you are building, for example, a Go application that uses the state management system. And the state management system then turns around and there's an implementation per cloud. For Azure, for example, most people, the Dapr provider is going after Cosmos DB as an optimized environment. For AWS, I've seen either DynamoDB and some other services that implement the state management capabilities. For Publish and Subscribe, I've seen implementations using Kafka, Event Hub, and other capabilities. So what the pattern here is exactly the same pattern as I walked you through with the Cosmos DB MongoDB API, where in this case, we are proposing as part of the Dapr community a set of capabilities, microservices, expose them as a gRPC or HTTPS API, which means you can bind it to any language. And then underneath the service-to-service invocation or state management is a cloud native implementation that is optimized for Azure, AWS, GCP, or VMware. And it's really great to see that the community has been absolutely superb, putting more capabilities up and providing implementations on a cloud optimized way that allows your application to be absolutely independent of the cloud environment, but allows the cloud provider to effectively bind what they believe the optimized implementation of that specific microservice capability is. The other half of Dapr, which is important, Dapr is very lightweight. I think the runtime at this point is 4 megabyte in RAM, so very, very lightweight. It's extensible. So if you don't use all of these, you don't have to deploy all of these capabilities. We have already seen extensions, not only removing things, but also adding capabilities, because we certainly don't believe that Microsoft or even the Dapr community per se knows everything there is to know about everything, every scenario that you might want to care about. And so my view is thinking through what the microservices are that you believe are important, proposing it to the Dapr community, working with the Dapr community is a key way of moving forward, building these cloud agnostic applications and building them in an optimized fashion for your scenario, hosting then optimized on a cloud environment of your choice, using whatever the cloud environment is that you prefer. Sidecar architecture, I already mentioned this, effectively injecting it in various ways depending on the environment, how you dynamically load based upon the service invocation that you're driving. Here is how an implementation works on the local side. You can see bindings to AWS or GCP and so forth. And here is the Rudder implementation, as I mentioned before, as an example for Kubernetes. So that might be another way of thinking about how you build your Kubernetes applications, where you effectively just inject the sidecar or you run the sidecar as its own independent pod, et cetera, et cetera. If you want to contribute Dapper.io is the all-up website. There is a GitHub repository for you to participate and learn, obviously, how Dapper works. It's a really vibrant community by now, and certainly one way of how you build these cloud native applications that are cloud optimized based upon PaaS services or other implementation choices that either the community or the cloud provider makes to support this cloud agnostic application runtime. And it's not only cloud, but also edge agnostic. So that's certainly an area where I believe we will see a lot of innovation coming down the line. Let's talk a little bit about management before we go into Q&A, because building the applications is one thing. And now you have multiple cloud environments, or you're trying to deploy on multiple edges. How do you manage all of this stuff? And as you can see, the world is getting more complicated, not less. We have lots of applications. We have a complex set of infrastructure with multiple cloud providers. And the interesting thing is there are a lot of use cases. Why hybrid edge capabilities or capabilities where you run on multiple clouds makes a lot of sense, partially because of risk management, partially also because of just latency, security, regulatory compliance, where, let's say, you want to deploy a tax management solution in an environment, let's say, called Turkey. There are no cloud providers, at least not the hyperscalers, available inside Turkey. So being able to run a solution locally on an edge environment is the only way you can really provide a capability there. Solutions like Dapper, Kubernetes, and so forth give you the infrastructure and programming model to build the apps, but now you have to manage them. I'm going to use the Azure environment, but there are other examples out there, like, for example, Google's Anthos is a similar model. I just am the Microsoft person, so I'm using Azure as the example. But again, Google Anthos works very similarly. In this case here, you see the way Azure manages things. So you have the portal, various APIs, shells, bash, et cetera, and then you have the Azure Resource Manager, ARM, as a system that deals with security, environments and automation, governance, policy, and so forth. And then you have management services on top, with the various Azure services effectively being managed here. This is the way cloud manages all of its resources. And again, you can get a similar picture for GCP. You can get a similar picture for AWS. The words vary, but the concepts will certainly be very common. And what Anthos has done and what Azure Arc has done is effectively extending that resource management paradigm over into edge environments. So on Azure Arc, you can now take the capability and install an agent in a virtual machine or a pod on top of a Kubernetes infrastructure that allows you to register those virtual machines and Kubernetes environments, being them running on VMware, be they running on AWS, GCP, or wherever, and register them with Azure as if there were Azure resources. And all of a sudden, you see, for example, a Tanzu or an open Shift cluster running on a VMware environment showing up in the Azure portal as a Azure native resource. Now, why would you want to do that? Well, if you have picked, in this case, Azure as your center of gravity, where you manage your cloud environments, it makes a lot of sense to extend that management paradigm over into VMware or other cloud environments, because you get a single pane of glass, you get a single pane of models of how you invest them, and so forth. Is this ultimately proprietary? Yes, it is. So Anthos or Azure Arc are obviously technologies of their specific vendors. But for example, the way Azure Arc supports Kubernetes applications, today only Microsoft ones, but we're working on extending this to third parties, is actually not proprietary. You just define a custom resource definition, CRDs, on Kubernetes, for example. And we, as the Azure Arc team, takes this CRD and does the necessary transformation into an Azure resource definition. And it's a really elegant way for you to, as an application developer, stay independent of the management paradigm, but at the same time being able to support, for example, a single management model and single management paradigm. If you don't do it this way, obviously all of the capabilities that you are seeing here, like RBAC, backup, those kind of things, would be something that you have to solve for each environment. And therefore, I do believe we will see more of these hybrid management capabilities. Again, Azure and Anthos are the two that are very prominent right now, but I'm sure other capabilities will emerge that do something similar, really taking all of these separate environments and bringing them under a single management paradigm to help with the proliferation of execution location, at the same time making it possible for a customer to operate it in an optimized and single fashion. So in summary, cloud agnostic is one way of things that will come, but cloud agnostic with cloud optimization underneath specific APIs, be that CNCF systems and or open source environments like Dapper. And so I think we are certainly a long way on this right path. There's still testing that you need to do. So if you really want to run and make sure that you can run on multiple cloud environments, you still have to test for compatibility, because people make extensions, people change maybe subtly some semantics on specific APIs. So you still have to make sure that the hosting environment that you pick for your target and potential fallback options are available for your development teams to test. Management, as I walked you through, is an area where you see mostly proprietary options, be there from the major vendors or be there from independent vendors like ServiceNow and so forth. But ultimately, ServiceNow, while great technology, is proprietary. It just doesn't happen to come from Google, Microsoft, or Amazon. It comes from ServiceNow as a company. Billing, cost management is something that is not solved in cloud. It's really, to a degree, embarrassing, because the telco world has solved this since quite some time. IDA never think about roaming costs. It just happens, and there's ways for the service providers to charge each other. I do believe that that's an area where we do need some more work and alignment. And then last but not least, despite all of this, you still will need investing in skills that are specific to a specific concrete hosting environment. Let's say you're deploying on GCP and Azure, you do need GCP skills and you do need Azure skills, not necessarily a lot, because again, your solutions are multi-cloud and they are cloud agnostically built. But if stuff doesn't work, if you do need to debug, if you do need to troubleshoot, there's certainly a lot of know-how that is specific to the way the cloud operates. The details do matter in certain things like networking and others. So from my perspective, an area where the companies do need skills or do need to hire skills that are optimized for a specific hosting environment. With that, I'm done with my presentation, and obviously am very pleased that you 81 people hung in here that long, and certainly looking forward to questions if you have any. I want to pause here and see if there are any questions.
Yeah, so Uli, we have a couple questions already. And again, if you have a question for Uli, please put them in the question pane at this time. Could you talk about how you measure the technical debt as all these choices build up?
It's an interesting one. So the thing is, I personally I like the way I think about this. The Burkholz accordion is one of the ways where you're looking at innovation versus standards. And the standards will give you lower technical debt simply because they have been around longer. There are more choices of implementation. Either there's just one implementation, everybody does it the same way, TCP/IP, or there are fewer choices because people have made their choices already. So for me, standards will be lower technical debt, whereas innovation and discoveries will increase the technical debt because those might fade because they just might not make it, OpenStack being a great example, or they just are proprietary and you still try to build this cloud agnostic thing. So for me, if you go into the technical debt measurements, the more standards de facto or de jure you can use, the lower the debt is. And obviously the innovation side, that's where you need to be more careful. On the other side, you can also argue, and again, I'm going to give you two perspectives here, that standards, because they are taking so much time and there's certainly a time lag, will also give you technical debt because they might not be modern after a while anymore. If you say, hey, I've standardized on ANSI SQL and relational databases are the answer to everything, you personally will have a lot of technical debt because the paradigms of NoSQL, graph, and other things really help solution development. And so thinking it through from multiple dimensions to determine technical debt, I think, is a very healthy way of thinking about it.
Okay. Do you have an example of how to manage multiple clouds? For example, having operational systems on Azure and analytic systems on AWS.
Yeah, it's a very, very good question. As I pointed out, this management thing is an emerging theme. Again, you see Azure Arc and you see the Anthos as two paradigms that are coming out. And both of them effectively assume that you run solutions, if you're not running them on Azure or GCP respectively, you run them on Kubernetes. And that certainly is not the assumption you can make with a lot of analytic systems and so forth. So most likely you will have to go a different route, which you partner with somebody like ServiceNow, who is building mostly focused on ITSM, but they're building connectors to all the services out there that are effectively running on multiple clouds. But it's a very imperfect world with respect to management. And again, it's only getting better in the Kubernetes application world. So if you run things on Kubernetes, you will have open or at least centralized management. If you don't run them on Kubernetes, the world is certainly very proprietary at this point in time.
All right. Again, if you have questions for Uli, come now in the question pane. Next question asked, on your last slide, we saw management, billing, cost, but what about the security controls and governance models across clouds, which I see is one of the biggest challenges asked of today?
Yep, and that's where you come into the skills across clouds business. The Kubernetes or CNCF environment, to be more broad, does have a bunch of standardizations going on with respect to security and other models like policy and so forth, even monitoring, with Prometheus being the standard for Kubernetes management. But underneath the covers, you still have to deal with the specific hosting environment. And that's where the skills across clouds come happen. And so the way I personally believe this will evolve is that the CNCF model will prevail for specific scenarios, but you still will need a very competent team that deals with the specifics for your hosting environment. I don't believe that you will see the world emerge into everything is the same and everything is standardized. The world is just too complicated for that. But I do believe that the CNCF environment will provide a fairly rich security model that then allows you to move the majority of your efforts into that and the minority of your effort into making sure that the infrastructure is available to host those Kubernetes-based capabilities. But it's not a pretty picture from a multi-cloud perspective. Sorry.
No. Are there any more questions for Uli at this time? Please come now into enter your question into the question panel.
It's a complicated topic, so it's a great conversation to have, and certainly I think as a software architect, something that we should spend more time on.
Right on. And again, Uli's presentation will be available in the coming few days and weeks. They'll be in our Web Summit community. We'll have a copy of the presentation along with his slides for you to review later. Again, that's for full members. If you're not a full member, I do encourage you to join ISA membership today. Any more questions for Uli while we have Uli on the line? Uli, do you have any final parting words you would like to share with the audience?
Nope. The only thing I already mentioned a couple of times, complicated topic. I think the community should get engaged, and we should certainly look into how do we help our clients be successful in this complex world. So things like CNCF, join if you haven't as an organization. Look at things like Dapper and other efforts that are out there to really help improve building these applications that are on the one side cloud agnostic, but can be run in an optimized fashion on the target cloud that you or your client is ultimately choosing.